Morning, everybody. Hope you're having a great day. Today on Code Forces, we have Kotlin Heroes Contest 6. So that should be very exciting. What is this? IntelliJ IDEA is what I'm looking for. Kotlin Heroes starts in a minute, and we have a Div 1 round tomorrow. That's super early. Oh boy. Hopefully I am not tired at 4:30 a.m. because the last time I did a Code Forces round at 4:30 a.m. it turned out not very well. Okay, so the hope for Kotlin Heroes is to get top 50 because then we're guaranteed a t-shirt. So that is the dream. Whether we can do it or not is very sketchy at best because this is only my second contest in my life that I'm competing in Kotlin for. So I don't really know what I'm doing, but I'm excited, nevertheless. Yeah, it's also only my second contest in my life that I've used IntelliJ for. Okay, no tips of the day, please. Well, whatever, we'll leave it, I guess. All right. Let's go. From 0 to y, you're given two positive integers, x and y. There's a variable k set to 0. You can perform the following operations. Add 1 to k. Add x times 10 to the p to k for some non-negative integer p. Find the minimum operations to set k to y. So sum of digits. So why is the first one not? We're given x. Gotcha. So you can add 2 any number of times and then plus 1. Gotcha. So we do we do each digit separately? Maybe. I don't actually know, it's not obvious. Regular bracket sequence is a string containing only open and closed brackets. For example, this and this are regular. The resulting expressions are, You're given a string, which is a regular bracket sequence. You can apply any number of operations to the string. Each operation can have one of the following types. Choose some non-empty prefix, remove it. So S is still a regular bracket sequence. You can remove this, gotcha. Choose some continuous non-empty substring and remove it from S. So you can remove a prefix or a suffix. The operation 2 can be applied at most k times. Calculate the maximum number of operations you can until S becomes empty. So in this case, you can do three things. In this case, you can do just the one, or you can do two, I guess. You can remove this and then the whole thing. So the question is, how many times can we remove some substring in the middle? Yeah. So how many times does the prefix hit 0? Is what we're interested in. Okay. So then we have N and K. Okay, so we have these variables now, and then we want to see how many times the prefix sum equals 0. So if C is equal to open bracket, then pre-sum plus plus, else pre-sum minus minus, 0 count equals 0. Yeah, good. So I think that's the way to do it, but we'll see in just a moment. Four, three, two, good. Okay, we got B. C has one solve. I guess we'll read it. We should also, A looks like it's not hard too. There's a street that can be represented as an array of length n. There are two policemen patrolling the street. The first one is standing at point I on the street. Second one is standing at point Y. Excuse me, points X and Y. During 1 minute, both policemen can decide what to do: move left, move right, or do nothing. What's visible? Oh, each point is visited by at least one. You have the n spaces, x and y. Sum of n is small enough, we can iterate over the split point and then solve it after that. Yep. What have I done? Well, it doesn't really matter. We can just delete all this anyway. Alright, so val n xy equals read line back to int. Dot split on a space dot map it to int. Alright, so now we need to work on the split point for split in 1 until n plus 1. Yes, until n. Yeah. So val size 1 equals split minus 1, size 2 equals n. Yeah, wait, okay, so how many things are in the first size? There's split things. And then our offset from the first is x minus 1. Size 2 contains n minus split things. And split is the first index. No, split plus 1 is the first index. So now we need this, so right. Okay, so if x is less than or equal to 0, return size minus x, or size minus 1 minus x. So let's say x is -1, size is 1, and we want to return size minus x. Yeah, or size minus 1 minus x. Okay? If x is greater than or equal to size minus 1, then return x. Otherwise, then size minus 1 plus min of x and size minus x. Size minus 1 minus x, I guess. Nope, oops. Come on, let me import this, please. All right. Ants equals the min of ants and max of count size 1 x1 count size 2 and x2. then print line x the end. It's gonna run B again. Nope, please run C. Two, so the second one does not take 6, it takes 3. There's one at 7, one at 1. Okay, so this is really size 1. Oh, gotcha, yeah. Two, 3, 5, 4, 0, 12. Looks good. I think, assuming samples are strong. I didn't actually read what the samples are. We should probably solve A. That might be a good idea, huh? Yes, D has solves. A has lots of solves, though. Sure, let's read it. Okay. How are we doing? We're doing alright. Let's read A. Let's read A. From 0 to Y, okay. Alright, so everything we add here for step 2, like this is just whatever's left. Everything we add for step 2 is a factor of x. So we know how many factors of x we want to add. We definitely want to add all of them because x is always at least 1. And then we just add the decimal sum, right? So whatever that number is in base 10, we just add that. Okay. Yeah, so it's multi-test case, right? So let's copy this. We don't need this here, so we want some count. Good, okay, so we have val x and y. Alright, so we have this. Val times will be y over x. So their total is initially y mod x total plus equals count of times. What's wrong with this? Oh, it's never used? That's it? Okay. Nope. I've done it again. Does this say it's recursive? That's kind of cool. Okay. We can't do this. Split on a space, dot map, int to int. Or 520. Looks good. Submit. I gotta say, one of the things I really like about whatever this program is called, IntelliJ, is that so many times it's like, you should just do this cleaner thing instead, and then it just does it for you. It's very nice. Okay, problem D, problem solving marathon. So this contest is, how many problems do we have? J problems on a Code Forces round? Oh, that's harder than a global round. Polycarp has decided to do a problem-solving marathon. He wants to solve S problems in N days. Let AI be the number of problems he solves during the ith day. He wants the final distribution of problems into days, such that it's an integer for all I, from 1 to n. It's greater than 1. AI is greater, okay, so they are increasing. Each of them are greater than 1. It, like, doesn't double, and it's maximized. Wait, what? Guarantee the distribution always exists within the given constraints. AI is an integer value I. Why can they not all just be the same? Oh, so 2, 3, 4, and 2, 4. So we want a sequence of integers. We want their sum to be equal to this last value.
I'm not sure how long to set it for.
We have company? Alright, oh well, zero's just gonna have to die over there. Yeah, so 1 element, 3 elements that sum to 9 are 3, 4, 5. So we could binary search for it. That might be a bit excessive. Multi-test case, right? So read line dot split on space. Nope, just that 2 ints. Okay. What is n again? Oh yeah, the number of things. Oh, that can be long. Interesting. Okay, so yeah, how do we do this? So we want the smallest first value we can get. And then when we have this first value, the last one will be as big as possible. Can we just do 1, 2, 3, 4, 5, and then 6? Does that work? So now this can go from 6 all the way to 10 if we do that. Yeah, let's say 10 isn't big enough. So let's say our target needs to be more than 5. Then we increase everything by 1. So then we have 2, 3, 4, 5, 6. So we've gotten our plus 5 here. All right, so what do we have in sum suffix? We have a sum left, and then we have a start value. Ideally, we would like the sum left to be as big as possible, with the start value to be, like, it depends, I guess. We want it to be at least half as of the last element. So if we want like 10 things that sum, or like, let's say 5 things that sum to 10. Well, you can't do that. 5 things that sum to 20. We would have 1, 2, 3, 4. What do these sum to? 10? This is 10, and then we would need a 10. So that doesn't work, because 4 times 2 is 10. So if we make this a 5, then these sum to 11. Right? Yeah. So these sum to 11, then we make this a 9. Yeah, so basically we're going to be multiplying by 2 to the I each time. So we'll have like 1, 2, 3 for a bit. Then we'll have like some k. And then we have k, 2k, 4k, etc., 8k. So we need this to be big enough. This is a bit of an annoying problem, to be honest. Maybe let's read E. Palindromic doubles. Subsequence is a sequence can be maintained from another sequence by removing some elements without changing the order of the remaining one. Palindromic sequence is equal to its reverse. You're given a sequence. Any integers appears no more than twice. What is the length of the longest palindromic subsequence? Anything appears no more than twice. Well, we can do it with Mo's, I think. I like this problem more. Maybe Mo's isn't particularly helpful. Let me get some paper. Longest palindromic subsequence, huh? So we have like 2, 1, 3, 1, 5, 2. So in this case, you want the 2's to match, then you match the 1's, and then take the 3. So if we're at some given element, we know what its match is. So we're set there. So we want to figure that out. In order to do that, we want everything between it. So a 2D segment tree can do this for us if we have it. Is that a bit annoying? What if we swept from right to left? Yeah, so we can do a sweep like this. You do a sweep on one of them. And the other you do a seg tree query. So sweep plus seg tree. Good. So let's do an example. So the 5, there's just one of them. So we increment that. That's 1. The 1, well, I guess you can have 1 of any element. Yeah, okay. So if it's like the first time, you have +1 to the first. If it's the second time, you have +1 to me, and then like range query, range max, +1 or +2 for the second. Okay. Yeah. Good, good, good. What problem is this? This is E. I don't know how to do D. And then I guess let's also make this just a temp so we have it. Okay, so we want a class seg tree. This needs leftmost int. Val mid equals left. Init on init. What does this look like? Init, okay. Good. Okay, so now we need val lchild seg tree our child. I guess we'll make them variables then. Maybe not. Okay, so if leftmost is equal to rightmost, then lchild equals our child, or equals null. Then our child equals null. Else, val mid equals leftmost plus rightmost over 2. Lchild equals seg tree from leftmost to mid. Our child equals this from mid plus 1 to rightmost. These can be vowels as well now. Okay. What's wrong with this? Rightmost. Leftmost, okay. What else? Fun update. Index is an int. And then vowel set to it's an int. Okay, and then fun range max L is an int, R is an int, returns an int. Cool. So now we need var range max is an int equals 0. Good. So we probably want recalc. Yeah, so if leftmost is equal to rightmost, return. This dot. What do you mean? Hang on, can I not use this? Oh wait, do I need a, That's kind of weird. Do I need this? Is this required? It is. Okay, fun. Learn something new every problem, as they say. Okay, so if this is the case, then return. Otherwise, range max equals lchild dot range max or dot, I don't know. All right. Update. Otherwise, our child dot update index set 2. Good. So now we just have this part left, I think. Okay, so query the range max. If L is greater than rightmost, then return 0. If R is less than leftmost, return 0. If L is less than or equal to leftmost, and R is greater than or equal to rightmost, return range max. Otherwise, return max of lchild dot range Q max from L to R, and rchild dot range Q max from L to R. Come on, import please. Import. Import. It's good. Okay, so we have our seg tree done. What does this look like? So val n equals read line dot to int. Val a read line dot split on a space dot to int, or dot map to int. All right. So now we need index of. Yeah, okay, so val first index of equals int array. Look at me, so fancy, of size n plus 1. Fill it with -1s. We also want last index of. All right, for I in 0 until n, first index, or I guess this is last index of, at a at I equals I. Okay, this is n minus 1 down to 0. Let me just double check. Okay, 451, exactly what I want. Yeah, so print or set, this is going to be the first index of. All right, so seg tree from 0 to n minus 1. All right, so now var ants equals 0, print line ants. So for I in n minus 1 down to 0. All right, so we want to see, yeah, okay, so if I equals first or equals last index of at AI, then just set it to 1. Ants equals max of ants in 1. St dot update I to 1. Otherwise, update the last index of I to 1. Val tween equals st dot range q max from I plus 1, last index of a at I minus 1. ants equals max of ants between plus 2. And then st.update the last wait, okay, so don't update, yeah, this is wrong. So this should be update I. And this should be this to between plus 2. Okay, I think we're fine. Let's run this here. What's wrong? Run E, please. Six, no. Okay. Setting I to max at I. Five to 1, 4 to 1, 3 to 1. Uh-oh. Yeah, okay. Two between plus 2. Five to 6. Okay, 1, 1, 1, 2 to 2, 2 to 1, 3 gets set to 3. This is 3, yep. Why is this 6? That means between is 4. Oh, it should be max. And then we're good. Okay. Let's get rid of the setting part. Come on. This building is so slow. 5, 4, 1, 2, 3. Okay, so let's hope we don't run into issues with there being too much input. But I think it's n log n, so we should be good otherwise. 69th place, not anymore. Oh, that's kind of funny. Still 69th place. All right, let's move up a bit. Okay, D needs to happen. Yeah, D needs to happen. All right, this is kind of annoying. So, suppose we know the biggest value. If we know the biggest, then we can get the biggest sum and the smallest sum. We can also get anything in that range, obviously. So we can binary search that. Yeah, okay, the smallest is easy. Yeah, okay. So what is this? This is the number of days. Oh, I wanted that. Okay. So the minimum last element would be n, right? The maximum last element would be s. And that's it. Yeah. So it's always between n and s. So, okay. So while min decided to the max. If possible, ns mid. So if it's possible to do this, what do we do then? Let's think. We want the largest, oh, this needs to return an int. That's less than or equal to 0. Oh, we just care if the sum will be too big. Yeah, okay. Then min equals mid, else max equals mid minus 1. So all we have left is this, which we can do in logarithmic time. So, yeah. If the first n elements is big enough, or yeah, okay, wait. So we're worried about whether it's too big. Okay, so var prev equals n minus 1, right? Because it's got to be, it can't be any smaller than that. prev equals max of last prev and last plus 1 over 2. Okay. So now, if s is less than the sum of the first n numbers, which would be n times n minus 1 over 2, this could overflow though. Then return 1. Otherwise return possible. What needs to happen here? Okay, so n is n minus 1. Sum will be s minus the last. The last number will be the previous element. Okay. If n is equal to 0, return 0. How many test cases do we have? 1,000. This should be pretty quick. Okay, so return this. Try catch T. Return 2E18L. Is that legal? Nope. Okay, let's cast this to along. Let's do 318 here. S is less than this. Yeah, then it's not going to happen. Okay, I think I've handled overflow. Yeah, so I think we're fine here. Let's try this. Okay, something's wrong. +1. 15, not right, okay. So, possible with 2 and 6 is wrong. Possible, so n equals 2, s equals, what is the sum? Sum is equal to, oh, this is less than or equal to. Wait, sum is greater than or equal to the sum of the first n numbers. Yeah, okay. Still very wrong. So wrong, okay. So 15, I guess. So now this 2 and the 6 is what I'm interested in. All right. Debugging is a bit easier in Kotlin, despite the fact that it's annoying to run. Okay, so why is that? 264 returns 266 returns true. This should be mul safe. Okay, so something's going on here that's very wrong. Oops. If s is less than the max feature, let's just call that s. Or I guess this is like min possible with n. If this is greater than the sum, then return true. Well, that's not helpful. That's not helpful at all. Then that means the sum is too big. Yeah, so the sum is too big, so then return false. Otherwise, okay. Otherwise, if n is equal to 0, well, if last is equal to yeah, or last is equal to s, last is equal to n, then return true. Okay, let's try that. I think that's fine. It's going to be n log squared is the runtime then. 1544. Okay. Submit to problem D. Just make sure I don't have any multiplications in here. Darn. Why is that? There are a lot of reasons that can be wrong. Okay, let's try two numbers, sum to two numbers sum to that. Bunch of sixes and then a bunch of threes plus ones. Yeah, so like a bunch of threes and a four. Okay. What if we have four numbers that sum to 10? 1 plus 2 plus 3 plus 4 sums to 10, I think. We've got four numbers that sum to 15. In this case, the answer is 7. 1 plus 2 plus 3 plus 7. So these are 8. 2 and 5 are 5. So 1, 2, 3, or 1, 2, 4, 7. 11. Yeah, okay. So I guess this 13 might be more interesting. And the answer should be 6. Oh, wait. Greater than or equal to. So you can have a bunch of ones. Okay. Misreading the problem. Classic. Alright, so this is not the case. The min possible with this number of n's will be just n. Right? Yeah. Yeah. So if This is too big, it's impossible. Otherwise, last equals previous thing sealed. Okay. Six. So we could do 6, then we could do 3, then we could do 2, 1. So 1 plus 2 plus 3 is 6 plus 6, yeah, so 1 through 2, okay. I think that's right. What about 14? Well, yeah. What if we had like 10 things we wanted to sum to I think I might just be resubmitting this here. Okay. Read the problem carefully. Lesson of the day. No, still. Oh, man.
Probably got wrong answer test user.
Okay. So if the number of things I need is greater than my sum, return false. I shouldn't need this anymore. If n equals 0, if n is greater than s, return false. Anything bigger than you can have, because you can increase stuff by 1. If n equals 0, return false. All the elements are positive. An integer value, wait, from 1 to n. One to n. 1 to n. Yeah, okay. What am I doing? This is not even close. Okay. Minimum is 1, maximum is n. Yeah. 1L. 2, 1. Get the min. If it's possible, we're good. Otherwise, if it's not possible, why would it be not possible? Because we're too big. So this was 100% a bug. This is also a bug, I think. Or I guess, yeah. I guess it was a bug, probably. Right. So resubmit that. Messy contest. Kind of gross. Let's move on to the real problems now. Oh no. Oh no. What have I done? Oh no. Oh, I'm a fool. I hope I don't get penalized for that. Oh my goodness. 1, 3, 2. Ah, yikes. What? What? If n is greater than s, return false. This is not right. Wait a minute, what? Oh, it's an integer value for all I from 1 to n. Yeah. So that was one bug. Here's the next bug. This needs to be up to s. What am I doing? So 1 to 15. 16, good. Okay, comment this out. Run samples. Pass samples, submit code, get the problem right, move on to problem F, get it right, and actually do decent in the set. What a great plan that is. Let's do it. What do you say? Step 1 is to get this right, though. Accepted. Good. Dogecoin! Hoorah! Okay, how are we doing? Are we back on track? A little bit, but not in a great place. We gotta get this. Cryptocurrencies had become increasingly popular. Anne decided that it was time she started mining the Dogecoin cryptocurrency. Anne's computer's not very powerful, so it mines exactly 1 Dogecoin per day. On the internet, there are forecasts of the cost of 1 Dogecoin over the next n days. Every day, she can sell any amount of Dogecoin she has. Note, if she mined Dogecoin the ith day, she can sell it the same day. She has not yet decided when to start mining. She's prepared Q possible plans. Each of them wants to know the maximum profit she can get. Each plan is described as 2 integers, the first and last day. Note, she should not have any on the th day. This is the cost. Can she buy them? I guess she can't buy them. Yeah, I guess she can't reinvest her money. Okay. So there are a bunch of costs. So the costs are 4, 1, 2, 3, 2. So 1 to 5, you would have, let's do it on paper. 1 to 5, day 1 you have 4, day 2 you have 3. This day you have 3. And then you have 2. 4, 3, 3, 2. Wait, what? Oh, 3, 3, 3. Okay, so this is 9 plus 6 is 15. I think I understand the problem. Let's do this real quick. So this is 9. Yep. 3 to 5. 3, 4, 5. 3, 3, 2. Yeah. 5 to 5. Just 2. Okay. So we have a bunch of elements. We've got a bunch of LR queries. Each time for each thing, we want the first max after it, or there is no, yeah, it's kind of tricky. So we want, like, every time you have we've got like a monotonic chain of like, this is the maximum of the suffix. Okay. Yeah. Cool problem. I like the problem. Don't know how to do it immediately. Let's see. So if you have some range, each element needs to add the max of this range. So plus this, plus this, plus this, plus this, plus this. So I think we can go left to right with all of our queries at once. So we have all of these things. We say, okay, so we have a range started. That range ends here. We want to know how many times is this used? Oh, that'll just give us the sum across all queries, though. Yeah. All right, be right back. Can we do Mo's? We want to know biggest thing in suffix, or biggest thing after each value in the range. Yeah. How long is this taking people to solve? Decent amount of time. Colin's doing great. I've gone with Mo's quite a bit recently, so maybe I'm overdoing Mo's, but I think I can get this problem in an hour. I think that might be the contest. 23 solves. This next one has 12. Should we read it? Given an integer n, each integer from 1 to n, all of them are pairwise distinct. Oh, n integers, so we're given a permutation. You have to paint them red or blue. The cost of painting a number of pairs, x, y. Oh, the number of pairs. Yeah, I like this one more. I like Dogecoin more. So we can have an array, or I guess what do we want? A stack? Yeah, right, so as you go right, the values you pick get lower. So moving the left pointer is pretty easy. We just add if biggest or skip otherwise, or like otherwise add to biggest range. Oh wait, how big is 300 squared? Oh, that's not big enough. Uh-oh. Or 10 to the 8. Oh, it's gonna be close. Okay, so if we go right, what if we move the right pointer over? What happens then? If we move the right pointer, we replace, yeah, just replace if it's newer, or if it's not newer. Or add the rest. I think we can do that. All right. Single test case. Okay, so data class query val, what is this? LR val block will be L over block size. These are all small, right? How big are the numbers? Up to 10 to the 6. Okay. So now we want array query queries and sorted equals, this isn't a data class, var ans equals 0 or -1, I guess. Queries unsorted equals array query. How many are there? There are q of them. And queries, each of them will be one of these. So val lr equals read the line split on space dot toInt. These things. Kind of weird that I'm not returning to this, but all right. All right. See if we're reading input correctly even. Resolved compilation problem. Query. Yeah, I think that's fine. Okay. Queries equals where unsorted dot clone. All right, let's pause for just a moment. I think if there's an easier way of doing this. Other than Moz, can we do it without Moz? As the right pointer moves over, we change a continuous range. Ah, that's it. Yeah. Okay. So as the right pointer moves, when the right pointer moves over by 1, we'll range set. And then we have a segment tree with range set and range sum. Okay. So easy peasy. All right, for character Q in queries unsorted, then okay, wait, no. Print queries unsorted dot map it dot ants dot join to string space. Make this a print line. Now I print it at the end. Okay. Val set to is an int. Equals -1, and then there's sum long sum equals 0L. Okay. Prop. If leftmost equals rightmost, set to. Okay, so if set2 is not or is equal to -1, these all have to be positive, right? Yep. Then return leftmost equals rightmost, then range max. We want range sum. Yeah. Then sum equals set2. Long. Return. Otherwise, set2 equals -1. Lchild dot range set from leftmost to rightmost to set2. child dot range set. That's what I'm doing right here. Range set. Come on, range set. What's wrong? Why are we not compiling? Oh, this. Okay. So if to set, or if set 2 equals -1, return set 2, return sum, return set 2 times our rightmost minus leftmost. This one. Good. All right. So return sum needs to be a long. Turn this thing right here is what it is. Okay, well, we won't worry about that for a bit. What's wrong? Redeclaration seg tree. Where's the other seg tree? This is so annoying. Why do we need to be like this? Come on. Are you better? Good. Okay. What's wrong? Okay, all right. Recalc. So we need to recalculate the sum. Leftmost equals rightmost. Return sum equals L child dot sum plus R child dot sum. Propagate. Recalc. Well, yeah, I guess we'll recalculate after we propagate. Sure, that's fine. Set 2 equals -1. Set the left child. Set the right child. Good. Okay, so we've propped. This is the sum. Query the range sum. Otherwise, we are prop. And then answer it for your kids. Yep. Okay. That's this range sum. Now we need range set. So we have these 3 cases here. Then just return. Otherwise, set 2 equals set 2. Return. Otherwise, we prop, and then we call range set on both of these. Okay, good. Range query sum, good. All right, so queries dot sort by queries dot dot r dot, what is this called? Awesome. So we have this. We're sorting these queries. Now we need to answer them. We also need our seg tree. Val st equals seg tree from leftmost to rightmost. Leftmost is 0, rightmost is -1. We also need to stack. Okay, Kotlin stack. How much time do I have? 44 minutes. 2 problems? Maybe. We'll see. Stack. Okay. Val stack equals stack of integer. For I in range 0 to n, or in 0 until n. Okay, good. What are we doing here? Val cur will be a at I. Yeah, okay, so if stack wait, so we need to answer, okay, yep. Answer queries with right okay, so we'll do that in a minute. So now we need to update the seg tree. So how do we do this? Yeah, so if stack dot is empty, then I guess just while not stack dot is empty, and stack dot peak is less than or equal to cur. Stack dot remove stack dot pop, I guess. Stack dot add cur. Oh, these need to be, okay, this needs to be just the index. Okay, what are we doing here? Well, this is less than cur, pop, add this int. We need to do some seg tree updates here. It's empty, 0, else stack dot peak, this one. St dot range set from previous to I set to at I. While q index less than n queries, and queries at q index dot r is equal to I, then we want to say queries at q index dot ans is equal to st dot range query sum. Leftmost will be queries, okay. Come on, what's wrong with this? Long, is the answer not a long? -1, good, we don't need the block anymore. And what's going on here? Do the answer. Okay, but L-1 and R-1. What? Yellow. Really? What could be wrong here? What could we possibly be doing wrong? Range set. Oh, yep. Q index plus. Okay. Nine, not really right at all. Okay. All right, so we're processing that. Okay. Okay, and then processing I equals 0. Set 0 to 0 to 4. Processing I equals 1. Let's do this on paper. We have 4, 1, 2, 3, 2. Okay. Processing I equals 0. Set this to 4. Set this to 1. Set these both to 2. I equals 3. Set these all to 3. Answer to query is 9. Yeah, sure is. Processing I equals 4. Range set 4, 4 to 2. 0, 1, 2, 3, 4. So these are all 2. Answer to the first query is 0. What? What? Range sum? So my seg tree is broken? Sum. Range Q sum. L greater than rightmost. R is less than leftmost, or L is greater than rightmost, return 0. If L is less than or equal to leftmost, R is greater than return sum. Propagate. Turn left child dot range Q sum L to R plus right child dot range Q sum L to R. So what's my range set? If L is greater than rightmost, or R is less than leftmost, set to return, propagate, and then set both of these to each other. Okay. Oh, then recalc. Yeah, alright. Good. Real question is, do we need print writer for this? It'd be nice if we didn't. I'm going to go on a little bit of a limb here, and if this is the reason I don't get a shirt, I will be so mad. Come on. Okay, cool. Good. Probably should have used it, but that's fine. G. Alright, how are we doing? 41. Dangerously close to no shirt. How's Colin doing? Colin has G. Let's get G. 34 minutes left. You're given n integers. Each one is 1 to n. All of them pairwise distinct. You have to paint them red and blue. Each integer should have exactly one color. The cost of painting is the number of pairs x, y, such that y mod x equals 0. X, wait, what? Okay, so we have some numbers. We want to paint some red, some blue. We want the maximum number that are red. So we want, like, yeah, a pair of reds divisible by blue. Yeah, okay, I see. Oh, if exactly K should be red. I see. Gotcha. All right, so in this case, so we have the numbers 1, 2, 3, 4, 5, 6. So if 1 should be red, 2, 3, 4, 5, 6. Print how many integers? For each k from 1 to n. So if one integer is red, you're telling me there are 3 pairs? Oh, so really 5 are. So if they're all red, then the answer is 0. Okay. If they're all red, the answer is 0. If we have one small number, you can do this. If you have 2 small numbers, there are 6 pairs. You can do R and R, yeah? What if there are 3 small numbers? So what if we do R, R, R? We have 3 for the first, 2 for the second, 1 for the third. Here we have 5. 1, 2, 3, 4. Oh. Okay, 1, 2, 3. Then the last one we want to choose the 5. It's hit the fewest number of times. So we only lose 1. Yeah. Try it with 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So 1, we hit, yeah, all 10. 2, so we have 9 plus 1, 2, 3, 4. Yeah. 3, so now we have, okay, so first this is 10, then this is 9 and 4, and then it's 8, 4, 6, 9, 8, 4, 2. Okay, then we have an R. So 7, what is this? That's 7, this is 4, 3. This is still 2. 5 is a 2. Okay. Are there any wrong submits on this? There is one wrong. I'm curious. I don't want to mess this up here. Maybe you just take the thing. Take the thing with like the most. Like gain versus loss each time. Yeah, I think that's a way of doing it. Do I have a proof? No, I don't, to be honest. So we'll see. Okay, val n equals read line dot to it. What do we do then? PQ entry, so int d count or id count. Priority queue integer. PQ. priority queue int. What about priority queue string? Priority queue comparator. Okay. Return a dot. What is this comparator? All right, so for int I equals 1 plus plus. Oh, what do we want? We want a list of answers. So var answers equals list of int, readable list. Okay, answers dot reverse print line answers dot string join the space. All right, cool. So mutable list of all right, cool. Do we start with a 0 or do we end with a 0? Okay, add a 0. Answers dot add 0. For I in range or in 0 till end. Count int I, and then what else do we want? We want the used list. Used is Boolean array. All right. For I in X until use dot size count by step. Oh, you can do this. That's kind of cool. Step by I. Step by X. All right. Var count equals 0. Return count. This is returns an int. If not used at I, count plus plus. Okay, then in this case we want PQ entry, or it should be PQ dot add PQ entry. The ID is I. The value is count I used minus taken relied on. Or wait, what is this? Just taken? Just used even. Minus times relied on at I. Alright, so for I, or I guess this is just repeat n minus 1 times PQ entry best equals PQ best, or well, PQ dot peak dot excuse me, dot value, whoa, okay, peak dot value is not equal to count PQ dot peak dot index or dot ID x plus x used times relied on PQ dot peak dot ID PQ dot pop. All right, so well, each of these are the case. Then remove it. All right, so now, PQ dot remove. Used at to use equals true. To use dot ID. For x in, well, I guess I in to use plus to use until what's the max value n step by to use times relied on at I plus plus. Okay, then PQ dot add this. And then answers dot add to use. I think. How much time? 15 minutes. All right. Does this even work? Oh, all right. After the bathroom, be right back. so we're doing 0 until n. This should be 1 till n plus 1. What else? Repeat times n minus 1 times. Yeah, okay. Use should be n plus 1. This should also be n plus 1. Oh, do we also need all factors of ourselves here? Yeah, we might need all factors of ourselves. Okay, so what about this? we use 3. Why not 1? Okay. Why does it not use 1 first? Times relied on. Oh, it picks the worst thing first, probably. Yeah, okay. Negative int value. That's not right. uh, so you pick the 1 first. Instance of 2, benefit 1. Five returns 0. Yeah, okay. Hmm. 5 minutes. Not good. Not good at all. Not good. Yeah, okay, so 1 gives us 4. 5 should not give us 0, it should give us -1. Times relied on until n plus 1. One, two, three, 5. That makes sense, yeah. Okay. And then that's not what we're really after. What we're after is the counts. Var counts equals 0, or var sum equals 0L. Okay, actually it shouldn't be that big. Yeah, it's just 0. So then sum plus equals the value. Three, 5, see. 356650. 2 1 0 11 3 6 9 11 12 13 14 14 13 10 0. Okay, so we're gonna submit this. And then yeah, okay. Nope. Submit to G, and then we're going to modify it here to also update all factors of ourselves. Yeah, okay. Okay, so array, or okay, val factors of array, yeah, equals array of int list, mutable list of int. Okay, it's gonna TLE. I know it's gonna TLE. Oh no. Oh, how much time do we have? It's so slow. It's like in log squared or something. Okay, 4. This is so bad. Just barely out of time. Okay. Well, what's the time limit? Accepted.
One answer is beyond option G.
2 seconds. Oh my goodness. I hope there are no system tests. Really hope there are no system tests, because I want a shirt so badly. Okay, yeah, I'm just gonna cross my fingers and not resubmit. Anyway. GG. Wow, that contest was basically perfect. Do you need G in order to... Looks like I needed that in order to get my shirt. Ooh, are there system tests? There's no way they wouldn't have 10 to the 5th in it. Let me just try 10 to the 5th. Hang on. I can just run max case so easily. Expecting a variable name. Come on. Nope. Don't do that. Let me run. 10 to the 5th. Come on. 1, 2, 3, 4. 1, 2, 3, 4, 5. It's about 2 seconds. It's plausible. Aha! I've done it. System testing 99%. Yes, please. Looks like we just got a t-shirt, ladies and gentlemen. Woohoo! Kotlin smoked us, so did geothermal, by a whole problem. Tourist didn't even solve set, which means it's a well-written set. Or this is just cancer. Let's see. Does this look like cancer? No, this doesn't look like cancer. This looks reasonable, I think. Or maybe not. I don't know. I haven't actually read the problem. Yeah, I don't know. Might be just a lot of work, but still, -2. Not bad. Not bad if it were rated. Yeah, that's fun. Let's go. System testing. System testing is going to take like 10 seconds. It looks like we're done. Looks like system testing is it. So there you go. I'm not going to go over solutions to this round because, I don't know, like, they'll definitely have an editorial. And no one's doing this for Codeforce's problems. If you want that, you can do other Codeforce's things as well. But let's go. Shirt on my very first real Kotlin Heroes. I am so excited. So happy. Let me just make sure I got a shirt. Did I actually get a shirt? Top 50 would Kotlin Heroes t-shirts and an exclusive Kotlin sticker. All right, you want to see something? So I did World Finals for ICPC, right? And 2019. Kotlin was there. It was sponsored by Kotlin. Let's see, can we focus? Me out of the picture, doesn't focus on me. Well, anyway, yeah, I got my Kotlin sticker on my water bottle already, and JetBrains, and then IntelliJ on the back. You know, lots of stickers, lots of fun stuff. But an exclusive Kotlin sticker, oh my goodness, I would be so excited. Anyway, that was very fun. Thank you to the authors for the great contest. I enjoyed it. I had a bunch of fun. And there you go. I guess it looks like I'm fine. It looks like this hacky submission to G passed. I don't know why. Data structure is greedy? Well, okay, if you say so. But there you go. Yeah. I have no proof, but I have the right solution, I guess. Well, okay, that's all. Thanks for watching. I've got real stuff to go do with my life, and it's 9 a.m. But have a great day, and hope you want a Kotlin shirt too. Bye.